Okay, this lesson is on dimensional analysis. I pulled this from some other text, so it's not going to necessarily line up with what we have been doing. I think it's at 1.5, but don't worry about that. So specific objectives, students will understand that units provide meaning to numbers in a context. Units in an expression may be used as a guide for needed conversions. Students will be able to use units to determine the conversion factors are needed for dimensional analysis. Use dimensional analysis to convert units and rates. So our introduction here. Most numbers used in the real world have units attached to them, like miles per hour, kilometers per hour, or gallons, or miles per gallon, which clarify what the number is referring to. For example, gallon, dollars, meters, it could be dollars per gallon, miles and pounds. Some units are for geometric measurements such as area or volume. Many disciplines such as medicine or engineering have special units for their field. This lesson focuses on the valuable strategy for converting from one set of units to another. So it's called dimensional analysis. So you're going to really use this a lot if you're going to have a chemistry, physics class, maybe even biology. So, for example, a fraction with equivalent expressions in the numerator and denominator are equal to number 1. 3a over 3a is 1. 2 plus 5, which is 7, over 7 is 1. 7 cubic feet over 7 cubic feet is 1. Multiplying something by the number 1 does not change its value. It changes the appearance, but not the value. So multiplying 4.99 over 2 pounds, so 4.99 per 2 pounds times 1 is still 4.99 per 2 pounds. However, multiplying by a number 1 can be used to change the way something appears. So like I said, changes the appearance, but not the value. 4/5 is 4/5 times 2 over 2, which is 8 over 10. So 8 over 10 is still 4/5. When multiplying fractions, if a factor occurs in both numerator and denominator, it can be divided out. The common factor may be a number or a variable. For example, 3g over 7m times m over 2. So notice that these m's could divide out here. You have 3g over 7 times 2, so 3g over 14. And that's what your answer would be. You can divide out things. So it's important to know some unit conversions when doing these. So for example, 3 feet is 1 yard, so 3 feet over 1 yard is equal to 1. 1 yard over 3 feet is also equal to 1. And 1 hour is 60 minutes, so 1 hour over 60 minutes is 1, or 60 minutes over 1 hour is 1. So to use dimensional analysis methods, start with the original quantity and multiply it by the number 1, written as a conversion factor, that's key here, written as a conversion factor of the two units, so that the units you don't want can divide out the numerator and denominator. So convert 300 feet into yards. Start with 300, so 300 feet. Now we want yards, so we're going to put that on top and put feet on bottom. So feet on top here, feet on bottom here, they cancel out. So these, as you see here, divide out. 300 times 1 divided by 3, the 3, and the 300 divide to make that 100. So you get 100 yards. So that's also an example of like a football field, 100 yards plus the end zones. Convert 30 ounces of weight to the metric unit of grams. So we have to come up with what is the relationship between grams and ounces. And so what we do know is that 1 pound is 453.6 grams. So we have to work our way to that conversion. So 30 ounces over 1 times 1 pound over 16 ounces, that allows the ounces to divide out, gets us into pounds. And then the 453.6 grams per 1 pound allows pounds to divide out. So that's what we're doing here. Those go away, these go away. Leaves the units grams on top. So it's 30 times 453.6 divided by the 16 that's still here. And then we get 150.5 grams. That's dimensional analysis. I guess there is a video for you to watch. To create conversion factors equal to 1, you must know which units are equivalent. So here's a table of equivalencies. And you can peruse that as needed as you're doing the work. Okay, 16 ounces, 1 pound. 2,000 pounds is 1 ton. 2.2 pounds per kilogram. 1 pound per 453.6 grams. And what was I going to tell you about length? This is something I used this last summer. I went to Canada. Luckily, I was able to change all my settings in the truck to kilometers. But I did keep the temperature in terms of Fahrenheit. Because I use... Do we have Fahrenheit temperature? I don't think I have temperature on here. There's a different calculation for that. There's more involved with it because Fahrenheit for Celsius, 0 is freezing, 100 is boiling for water. So there's an addition and multiplication going on. Okay, so there's some important things here. I do want to point out some interesting things. 8 ounces is a cup, 2 cups is a pint, 2 pints is a quart, 4 quarts is a gallon. Okay, that's kind of a nice thing about our English system versus this boring system over here. 1,000 milliliters is a milliliter. Where's the fun in that? 1,000 liters is 1 cubic meter. That's an important one, actually, right there. I can see you using that a bit, especially if you're in engineering. And then 1 cubic foot is 7.481 gallons. Now, what do we have here? 1 quart is 0.946 liters. I thought it was, well, 4 quarts. So a gallon is somewhere around like 3.8. I see that written down sometimes. Okay. So looking here, converting a rate, so 200 cubic meters per hour. So we go back to the chart. We do 1,000 liters is 1 cubic meter. So what's our goal here? River flows at that. What's it in gallons? Okay, so we take this little journey to get to gallons. So we'd have cubic meters on top, cubic meters on bottom. They cancel. So we want it in seconds too. So we'll have to make that conversion. So we want to go liters. We have this quart to liters ratio. So liters here and liters on bottom gives us quart. Then we have quarts to gallons ratio or conversion there. Then we have to go time. So 1 hour, 60 minutes. So the hours would cancel with the hours here. 1 minute is 60 seconds. So minutes cancel here. And you end up with, if you do the math, 200 times 1,000 divided by 0.946 divided by 4, divided by 60, divided by 60. So make sure when you're doing this, you could just do divided by in parentheses, all these things together, close parenthesis. Otherwise, it's going to, as is shown right here, it would, if you said 1,000 divided by this times here, 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 it's going to be multiplying this calculation here by those. So doing divide, 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 make sure you do that correctly. Okay. In the U.S., we measure height in feet and inches. In other parts of the world, height is measured in meters. Use dimensional analysis to convert the height of a person who is 5 feet 10 inches to meters. So I'll come back here and I see the inches to centimeters relationship, and then we can build it up from there. So the 100 centimeters is a meter. So 1 inch is 2.54 centimeters. Okay, so we have, convert this to meters. So we have 70 inches times 2.54 centimeters per inch, and then times 1 meter per 100 centimeters. That allows the centimeters to divide out, inches to divide out, and we're left with just meters. So let me get my calculator out here. I don't drop it while I'm trying to open it. Okay. So we have 70 times 2.54 divided by 100. I come up with 1.778. Okay. In the U.S., we measure weight in pounds. In other parts of the world, weight is measured in kilograms. Use dimensional analysis to convert weight of a person who's 180 pounds into kilograms. So 180 pounds. I think we saw it earlier. Times 2. No. Where's my erase button on this? Times, wrong choice. This one. Times, did it again. Sure makes it hard on this one. Okay. There's erase. There we go. Come on. I'm using a different program to write on. It's not as smooth as the other one. 1 kilogram for 2.2 pounds. And what do we get out of that? So the pounds will divide out. So 180 divided by 2.2. I get 81.8. I'm going to round to two places. 2 kilograms. Because it's 8181881. Okay. Okay. Texting while driving. Washington state law. Person operating a moving non-commercial motor vehicle who, by means of whatever, the person might spend only 4 seconds to answer a text. How far will the car go in that time? It depends on the car's speed. So suppose the car is going 35 miles per hour. Before calculating what do you think is the distance the car would travel in 4 seconds, then we'll use dimensional analysis. I don't know, let's say 100 feet. I'm going to guess 100 feet. Okay. So 35 miles per hour times, so we don't know how far the car goes in seconds, and so we'll do feet. So it's 5,280 feet per mile times, then we can go to seconds, so we have 1 hour over 60 minutes times 1 minute over 60 seconds. So in that, the miles will divide out, the hours will divide out, the minutes will divide out. This will give us feet per second. Then we can multiply that by 4 seconds to come up with how far the person traveled in that time. So 35 times 5,280, divide that by 60, and then divide by 60 again. And I get 51, wow, that's more than I thought, 51.333 feet per second. So if you do 51.333 feet per second, I guess I could have just kept this as part of the string too. Times 4 seconds, that will cancel that out. And we're left with 205.33 feet the vehicle would have traveled at 35 miles an hour if you take your eyes off the road to answer a text or read a text. Okay, pretty scary. So this is doing the same kind of thing. Traveling 45 miles per hour. How far will it go in 4 seconds? So 45 miles per hour times 5,280 feet per mile times 1 hour over 60 minutes times 1 minute over 60 seconds times 4 seconds. And so in doing that, the miles will divide out, the hours will divide out, the minutes will divide out, the seconds will divide out, and we'll be left with, drum roll please, 45 times 5,280 divided by 60, divided by 60, times 4, 264 feet. Wow. Okay. If you are driving in Canada following posted speed limit of 80 kilometers per hour, how many feet would you go during the 4 seconds? Okay, same thing. So 80 kilometers per hour. We want feet though. I didn't see a conversion from feet to meters. I know it's a little over 3, so let me look at that real quick. May have to break it down to inches. Okay, the one I see here, we'll do the kilometers to miles. We'll do that conversion, and then we'll break that down to feet, the 5,280 feet per mile. Okay, so we said we go 1 mile. No. It was 0.62 miles. The calculation I did when I was in Canada was I just multiplied everything by 0.6. So 0.62 miles per 1 kilometer. Then we'll do 5,280 feet per mile. This is point. And then that gets us to feet. So kilometers are gone, miles are gone. Then times again 1 hour over 60 minutes. And then times 1 minute over 60 seconds. Times 4 seconds. So that lets our hours cancel, our minutes cancel, and our seconds cancel. So we do 80 times 0.62 times 5,280 divided by 60 divided by 60 times 4. And I get 290.98666666, and it rounds off, with a 7 there. So 987 feet. You could round it up to 291 feet if you want to the nearest whole foot. But that's not a big stretch either to go to 291. But there we go. Okay. If the typical texting response time is between 2 seconds and 6 seconds, in a car traveling at 35 miles per hour, what is the typical distance a car would travel during a typical texting response? So express the answer using inequality symbols. Okay, so we would look at 35 miles per hour times 5,280 feet per mile times 1 hour per 60 minutes times 1 minute per 60 seconds. Then we'll do it times 2 seconds. They'll do the same thing. 5,080 feet per mile. This lesson's getting a lot longer than I thought it'd be. Times 1 hour per 60 minutes. Times 1 minute per 60 seconds. Times 6 seconds. I could have just multiplied that answer by 3, couldn't I? Yep. So 35 times 5,280 divided by 60 times 2 is 102.67 feet. And we'll do the same thing times 3. It's going to be 308 feet. So it'd be 102.67 is less than the distance, less than 308. So that feet. Okay, I'm going to stop this video here. I'll make another one for the volume and area.